So today we're going to be covering 6-4, solving compound inequalities using AND. Okay, our main idea today is to solve the compound inequalities using the word and then graph their solution sets on a number line. Okay, so if you have colored pens or colored pencils, it'd be great if you could take those out so you can use it as we are doing the examples today. It also really helps when you're graphing it in two different colors when we look at the different cases. So just to go over some vocabulary, okay, the word compound, you may have heard it in other classes in science. We talk about compounds when we take different elements and put them together. In language arts, we talk about compounds as in compound words or compound sentences. So today for us, compound is one unit created by the combination of two or more other units. Examples taken from language arts: compound word, you take two words and you put them together to make one word. Example, everyone loves. Cup plus cake is cupcake. So that is a compound word. We made a new word out of two different words. Okay? So some other vocabulary terms we need to make sure we are all aware of. Compound sentences, which you're going to be working on. Okay? Compound sentences are sentences created by connecting two sentences using the word and the word or. And or. And a compound inequality is what we're going to be working with, and that is two or more inequalities that are connected by the words and or. So since these words and or are very important, we need to kind of take a look at them and see their differences right now. So I've created a little chart to help us. Okay, so here's an and versus or example. Okay, so here's a Venn diagram. I've got one set of numbers, set A, and I've got another set of numbers, set B. In set A, what numbers do I have? What's in the red circle? 1, 2, 4, and 5. And what's in set B in the blue circle? I've got the numbers 2, 3, 4, and 6. So that's set B. Now, what we're going to do is two different things. We're going to take a look at the word and first, and let's explore the word and. So, if I wanted set A and set B, okay, and I would be looking at what we call an intersection, okay? Intersection is when I take A and intersect it with B, much like what we did in Chapter 5 when we took two lines and intersected them. An intersection was where they crossed, where they overlapped. So an and is when the two sets overlap. So where does set A, the red set, overlap with the blue set? What numbers appear? Okay, what I'm looking for is where the solution is common to both of them. What numbers appear in both A and in B? Okay, and we use the symbol that looks like an upside down U, or some people say it looks like an N for and. Okay, and I'm looking for A and B, or A intersection B. What numbers do you think they are? What numbers are in A and B? Did you guess 2 and 4? If so, you are correct. The numbers 2 and 4 are both in A and in B. They have to be in both of them. Okay? So let's look on the other hand. Let's take a look at the word or. Or is what we call a union, when you join them together. What's in A or in B? That means joining them together. We want the answers that come from either A or B or both of them together. Okay? So the symbol is a U for union. Okay? And what numbers would be in A union B? A or B? The number 1 is in A or in B. 2 is in A or in B. 3, 4, 5, and 6. So if you guessed all of those numbers, you are correct. They're in both of them. Okay? Okay, so how does that relate to what we're going to do with our number lines? We're going to use these ideas, the overlap idea and the joining idea, and work on our inequalities. Today we're going to focus on the overlap case, the and case. Tomorrow we're going to work on examples with the or case, or the join case. Okay, so here's an example. So, example, can you graph y is greater than or equal to 5 and y is less than 12? You might want to take out two different colors. This is a great time to use two different colors to help you. You want to set up a number line like this, okay, that has the numbers 5 all the way to 12. So mine actually cover a little more. 5 starts here, 12 is here. And what we're going to do is we're going to leave some room up here because this is actually where we're going to show our work. Okay? So go ahead and set that up. I'm going to go ahead and graph the first one. Y is greater than or equal to 5. I'm going to do that one in green. Okay? So I'm going to graph it above my number line because this is where I'm going to show my work. I haven't come upon my actual final answer yet. Y is greater than or equal to 5, so I'm going to go to the 5 right above it. Greater than or equal to, so that means it's closed because it could be equal to 5. And it's greater than, which means I'm shade to the right because all these numbers are bigger than 5. Okay? Next, I'm going to go ahead and graph y is less than 12 in red. Less than 12, so here's my 12, open circle because it cannot include 12. Less than will go to the left, so those are all my numbers that are less than 12. Now, this is where the word and comes in. And means overlap. Intersection. Where do the green intersect with the red? Where do they overlap each other? Well, take a look. Let's see. It starts here because here's green and red. So I'm going to go ahead and shade this in because it has green and red. All this has green and red, So I'm going to shade it in right underneath. And then it looks like it stops right before the 12 because 12 is open. So what I'm going to do is add the 12. I'm going to also copy the open because it can't include 12. It's not equal to 12. It can only go up to it. So notice that it's in between the 5 all the way to 12, but not including 12. Okay? So this is how I would write my solution set for this. I'm using the variable y, so all these shaded numbers represent y. Y is less than 12 because it's not equal to it, but y is also greater than or equal to 5 because 5 is my other endpoint. So you'll notice 12 is on this side, 5 is on this side. This side is closed, so this is a closed sign. This is an open sign. Okay? And this is variable y is what we're using. So y such that 5 is less than or equal to y is less than 12 is the inequality for this graph. And this we call an in-between case. Okay, because it's between 5 and 12, not including 12. Okay, so it's your turn. My suggestion would be use different colors so you can take a look, so you can visually see where the two number lines overlap each other. Okay, and then on your number line, you're going to actually have your final answer. Okay, so give this a try. This is your turn. Go ahead and graph the solution set for a is greater than -5 and a is less than 0. Okay, you can pause here and give that a try. So how did you do? Let's take a look. Okay, so when you graphed it, you graphed each one separately. I have a is greater than -5. It's my blue line here. And then I graphed a is less than 0, my red line. They're both open circle this time. Then I overlap the two, open circle on both ends, and both ends in between, I've got red and blue, so I shaded it in purple. And since this was in between, I wrote my between case. So a is the variable that's represented by all the shading. It's less than 0, but it's also greater than -5, so it's stuck in between. And you'll notice that these are facing the same direction also. They always must face the same direction if you're doing an in-between case. Okay? And a is my variable, so I write a such that -5 is less than a is less than 0. How did you do? Okay, now let's move on to the next case. Okay, another problem they can present you with, here's example number 2. They ask you to solve, then graph. Well, you're probably taking a look at this saying, oh my gosh, they typed this wrong because you can't have two in the same problem. You can't have two inequalities. In fact, you can. And this is just like what we created earlier as our answer. This is actually 2 in 1. That's why it's called compound. So there's 2 separate problems here written as one. So what we're going to do is rewrite it as 2 separate problems again. So this is 7 is less than c plus 2. C plus 2 is in the middle, and we're going to use that as our overlap. And we also have C plus 2 is less than or equal to 11 is the other one. So then you solve each one, keeping in mind this is an AND case. Okay, so minus 2, I get C is greater than 5. And on this side, minus 2, then I get C is less than 9. Keep in mind this is AND again. AND means there's going to be an overlap. You take your two C's, if you overlap them, put them together, you'll notice on this side you have C is less than 9. Over here, you read it the other way though, because your variable's on the right-hand side. C is greater than 5. You're reading it backwards. C is greater than 5. And this is the set C. Okay? So here's our number line, and we're going to go ahead and graph it. Okay? And I have the numbers for 6, 8, 10, kind of laid it out here. And then 5 is open circle on the 5, and then open circle on that 9, and it's graphed right in between. Okay? And you can put a C there. Okay? So now it's your turn. You give it a try, solve it, then graph it. Remember to write it as two separate cases. Okay? So solve, then graph the solution set. Okay? You can pause right here and try it. See how you did. Separate cases, solved each one separately, then you combined it back together for a solution set, and then you graphed it, noticing one is closed circle this time, right? And you can mark it hard. Okay, so your turn. Tonight, give these a try in your workbook on page 77, problems 1, 2, 9, and 10, and bring it to class tomorrow. See you tomorrow.